Hello friends, I welcome you all to my channel. In this video is part of my playlist Maths 11 Limits, which is a playlist where I will be uploading videos on limits of class 11 mathematics. In this video, I will discuss how to find limits of algebraic expressions by the method of rationalization. Uh, so let's get started. Okay, so the objective is to find a given limit of the form fx by gx at x tending to a, where uh, limit x tending to a fx will be 0 and limit x tending to a gx will be 0, or limit of fx at x tending to a and limit of gx at x tending to a both will be infinity. So the form will be 0 by 0 or infinity by infinity, and fx and gx are algebraic expressions having roots. Either fx will have roots or gx will have roots or both will have roots. So uh, the problems of this category typically have this form. I've written down some standard forms. So it will be of the form like root over gx plus minus root over hx divided by px, where gx and hx are algebraic terms. Or it can be of the form root over gx plus minus a by px, where a is a constant and gx and px are algebraic terms. Or it can be of the form root over gx plus minus root over a by px, or it can be of the form root over gx plus minus root over hx divided by root over px plus minus root over qx, where qx is also a algebraic term. Now, to solve this kind of problem, the general method is we rationalize fx or gx or both to get rid of the roots, the term having roots. We then further simplify the rationalized limit function and apply the standard strategies of solving limits of the form 0 by 0 or infinity by infinity. Let's try some problems to understand how we solve this kind of limits. Okay, so the first problem is limit x tending to a root over a plus 2x minus root over 3x divided by root over 3a plus x minus 2 root x. So here both the numerator and denominator have roots. Now we have to see if we need to rationalize one of them or both of them. If we rationalize the numerator by multiplying with the conjugate term, we will have a minus x. So it will still be of the form 0 because x is tending to a. So, and if we rationalize the denominator with its conjugate term, we will get uh, we will get 3 3a minus 3x. So we can take 3 common and we will get a minus x. So we are getting a minus x and the term a minus x and also a minus x in the denominator. So that will get cancelled out. So we need to rationalize both numerator and denominator. So let's proceed. This becomes a plus 2x minus, if we rationalize this with its conjugate term, a plus 2x plus root 3x, and we also rationalize the denominator with its conjugate term, and we have this. Now after multiplying, we get, in the numerator we get a plus 2x minus 3x, and in the denominator we get 3a plus x minus 4x. Mm, mm, mm. Plus root 3x, so we get a plus 2x minus 3x, and a plus 2x, 3x, 2 root x. So plus we get 3a plus x minus 4x. This becomes uh, a minus x in the numerator divided by 3a minus 3x. This becomes limit x tending to a minus x, 3 common, a minus x. This is 1 by 3, as x tending to a implies x not equals to a, implies x minus a not equals to 0. Uh, Let me check once again if I did it correct or not. A plus 2x minus 3x over a 3a plus x minus 2x. If we rationalize the numerator, we are getting plus 3x. We are getting a plus 2x minus 3x. Okay. And in the numerator denominator, we are getting plus 3a plus x minus 4x, which becomes 3a minus 3x. So yeah, so this is the answer. Let's see the next problem. Problem number 2. So it says limit extending to 0 sin x divided by root x plus 1 minus root x minus 1. Sorry, it's 1 minus x. Okay, it's 1 minus x. So we are having roots in the denominator, and if we rationalize it, we will get x plus 1 minus 1 plus x. So 1 gets cancelled, we get twice x, and we can use that with the sin x in the numerator and apply the standard result sin x by x. So let's proceed. Sin x One second, one second. I think I have done something wrong in the previous problem because when I multiplied, when I rationalized this, I have to also multiply this term, adjust it, this term in the denominator. So, so this term would also be in the denominator and this term will be in the numerator. Sorry. So this will actually be over here we have 3a plus x plus 2 root x, and over here we have a plus 2x plus root 3x. So this is fine, and we will have 3a plus x plus 2 root x, and over here we will have a plus 2x plus root 3x. So after cancelling out the x minus a factor and substituting the value of x as a in the remaining terms, uh, we get over here 3a plus a 4a, so 4a, so 2 root a plus 2 root a, and over here we have a plus 2a 3a, root 3a plus root 3a, which becomes 4 root a, uh, which becomes 4 root a divided by 3 into 2 root uh, mm, a plus 2x plus 3x, 3a plus x plus 2x, so 3 plus x plus 2x, this becomes 2x, a plus 2x plus 3x. The numerator we get 3a plus a, which is 4a, so it becomes 2 root a plus 2 root a, and in the denominator we have root over a plus 2x, which becomes a plus 2a root over 3a plus root over 3a, so it becomes 2 to 4 root a divided by 3 into twice of so this becomes 2 root a gets cancelled, and we are left with 2 divided by 2 gets cancelled, and 3 root 3 3 root 3. Yeah, so this is the answer. Okay, let's carry on with the next problem. So, when we rationalize the numerator, the denominator, we get and we uh, also multiply the same thing with the numerator. So, this becomes sin x root over x plus 1, 1 minus x, and the rationalized term in the denominator becomes x plus 1 minus 1 minus x. So this becomes uh, sin x divided by 1 gets cancelled and we get 2x. So this is half, we bring the half outside and we have sin x by x, and we have x plus 1 plus 1 minus x. After substituting the standard result of sin x by x as 1 and the x as 0 in the remaining term, we get half into 1 into 0 plus 1 plus 1 minus 0. This is uh, half into 1 into 2. This is 1. 1 is the answer. Okay, let's see the next problem. The next problem says limit x tends to root over 10, 7 minus 2x root 5 minus root 2 divided by x square minus 10. So clearly both the when we substitute x as root 10, both the denominator is becoming 0 and the numerator is becoming 7 minus 2 root 10. 7 minus 2 root 10, and we have root 5 minus root 2, 7. 7 minus root 10. Root 10 is root 5 into root 2, and 7 is 5 plus 2. So we can see some kind of square in the first term of the numerator. Let's proceed. This is root 10. What if we rationalize the numerator? No. If we rationalize the numerator, the root, uh, the first term will become 7 minus 2x, and the second term whole square. Root 5 minus root 2 whole square is 7 minus 2 root 10. 7 gets cancelled and 2 root 10. 2 root 10. And Okay. So root 2 root 10. We can factorize the denominator as x minus root 10 into x plus root 10. Okay, let's see. Let's proceed by rationalizing the numerator. 7 minus 2x minus root 5 minus root 2 7 minus 2x plus root 5 minus root 2, and over here we have x square minus 10, and we have to adjust the 7 minus 2x plus root 5 minus root 2. If we simplify the numerator, we get 7 minus 2x minus root 5 minus root 2 whole square. This is 5 plus 2 minus 2 root 5 into root 2. And we have here this. Now this becomes 7 gets cancelled, and we get minus 2 plus 2 root 10. So clearly we can see, if you take 2 common, we will get x minus root 10. So we can here factorize this as x square minus 10. We can factorize it as x plus root 10 into x minus root 10. And we have this 7 minus 2x plus root 5 minus root 2. Okay. So this becomes x tending to root 10. Take minus 2 common, x minus root 10 divided by x minus root 10, x plus root 10 multiplied by 7 minus 2x plus this one. Now x minus root 10, x minus root 10 gets cancelled out. Now if we substitute x as root 10 in the remaining term, what do we get? This becomes minus 2 divided by x root 10 plus root 10, 2 root 10, and over here we have 7 minus 2 root 10 plus 5 this thing. Okay. 2 gets cancelled. Uh, hmm. Mm, 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 Okay, so this is minus root 10 okay, so we know that 7 minus root 10 is 5 plus 2 minus 2 into 5 into root 2. So complicated computation, but anyway we have to do it. Uh, uh, okay, so we have root 10. Over here we have this is root 5 minus root 2 whole square, and this is root 5 minus root 2. Okay, so this becomes minus root 10 uh, root 5 minus root 2 plus root 5 minus root 2. This is minus twice root 10 into root 5 minus root 2. If we rationalize the numerator, we get minus root 5 plus root 2 divided by 2 root 10 5 minus 2. This is minus root 5 root 2 3 6 root 10. Let me see this. We are having a minus. Why are we having minus? 7 minus 2x. When we rationalize the numerator, we are getting 7 minus 2x minus what do we get? 7 minus root x, and then root 5 minus root 2 whole square minus this. Okay, and then we are getting minus 2x plus okay, so this is the answer. I hope I did not do any mistake regarding the sign positive and it's coming negative. Please check it yourself, and if you see any mistake in my computation, please let me know in the comment section. I will highly appreciate that. So let's move on to question number example 4. Example 4. Example 4 says limit x tending to infinity root over x square plus x plus 1 minus x square plus 1. So we have only a single term and x is tending to infinity. So we are having the form infinity. The form is infinity minus infinity. Okay. If we rationalize this term, we will get x square plus x plus 1 minus x square minus 1. So x square gets cancelled out and we are left with x square and 1 gets cancelled out and we are left with x, and we will have uh, roots in the denominator. Okay, let's see. 1 minus x square plus 1 but divide with the same conjugate term plus 1, sorry, this will plus x square plus 1. So after rationalization, the numerator becomes x square plus x plus 1 minus x square plus 1, and we have here x square plus x plus 1 plus root over x square plus 1. This further becomes x by root over x square plus 1 plus root over x by 1. So x is tending to infinity. If we bring down the x, and if we bring down the x to the denominator and put the x inside both the uh, roots, both the terms with the roots, we get uh, we get when it gets inside the root, it will get inside as x square. So we get something like x square plus x plus 1 divided by x square plus x square plus 1 divided by x square. This further becomes 1 by root over 1 plus 1 by x plus 1 by x square plus root over 1 plus 1 by x square. Now x tending to infinity implies 1 by x tending to 1 by infinity tends to 0. Similarly, 1 by x square tending to 1 by infinity tends to 0. So we get the answer as 1 plus 0 plus 0 plus root over 1 plus 0. This is 1 by 2. 1 by 2 is the answer. Okay. So let's see the next problem. Example 5. It says limit x tending to infinity root x root over x plus c minus root x. So when x is infinity, so the first term is infinity and the second term is infinity minus infinity. So the form is actually infinity uh, infinity minus infinity. This is the form. Okay. So if we rationalize the second term, we will get x plus c minus x. So it will become c. So let's see what happens. Limit x tending to infinity root over x root over x plus c minus x into x plus c plus x divided by root over x plus c plus root x. After simplification, this becomes root x plus c minus x. So this further becomes c into root x divided by root over x plus c plus root x. Now we can take out root x common from both the terms in the denominator, and we get we get mm, root x common. So we get 1 plus c by x plus 1. So root x gets cancelled, and when x tends to infinity implies c by x tends to c by infinity tends to 0. So the answer becomes c by root over 1 plus 0 plus 1. This is c by, this is c by 2 is the answer. Okay. We will do the final example. Example number 6. It says limit x tending to infinity root over 1 plus x to the power 4 plus 1 plus x square divided by x square. So it is of the form, it is of the form infinity by infinity by infinity, which is basically infinity by infinity form. Now, if we rationalize the numerator, we will get 1 plus x to the power 4 minus 1 plus x square whole square. So definitely 1 and x to the power 4 will get cancelled, and we will be left with uh, minus 2x square, and we have in x square in the denominator. So let's proceed. uh, 1 plus x to the power 4 plus x square uh, mm, 1 plus x to the power 4 minus 1 plus x square. So after rationalization, the numerator becomes 1 plus x to the power 4 minus 1 plus x square whole square, which is 1 plus x to the power 4 plus 2 x square. Uh, hmm, hmm, a plus x square minus 1 plus x square minus 1 x square. We multiply the numerator. The numerator is becoming 1 plus x to the power 4 minus x to the whole square, 1 plus 4 plus x square. This becomes minus 2x square hmm, hmm, minus 2x square hmm, x square 1 plus x to the power 4 minus 1 plus x square. X square gets cancelled. We are left with this, and in the denominator, we are having the form infinity minus infinity. Hmm, I'm not sure if the question I have taken is, if I've incorrectly taken the question from the source. Let me check once again if I did it right or not. If I rationalize the numerator, I'm getting this minus this, okay. So 1 plus x to the power 4 minus 1 plus x square whole square, it becomes 1 plus the 4 plus 2x square. On in the denominator with x square, 1 1 plus x to the 4 minus 1 plus x square. So now x square gets cancelled. X square gets cancelled. We are left with minus 2x square by x square. This is becoming 1 by infinity minus infinity form. I multiply this again. Multiply this again by instead of rationalization, if we simply divide, the numerator uh, by x square, what do we get? Okay, so it's quite easy actually. We do not need to do rationalization. We can simply, these steps is not actually required. I'm sorry. We can straight away divide the numerator, the terms of the numerator by x square. So it becomes root over, when x square gets inside root, it becomes x to the power 4. So we have 1 plus x to the power 4 divided by x to the power 4, and over here we have plus 1 plus x square divided by x square. So this becomes root 1 by x to the power 4 plus 1, and this becomes 1 by x square plus 1. 1 by x square plus 1. Hmm. So x to the power 4 on the x to the power plus 1 and 1 by x square plus 1. So when we substitute, so when x tending to infinity, this implies 1 by x square tending to 1 by infinity tending to 0, also 1 by x to the power 4 tending to 1 by infinity tending to 0. So this limit becomes 0 plus 1 plus 0 plus 1, which is 2. So the answer is 2. Okay. So that was all for the sample problems. Uh, I hope this video helped you to understand how to solve limits by the method of rationalization, and I have prepared a set of practice problems. The link of the PDF I will provide in the description below. So if you like this video and if you find this video useful and beneficial, then please share it with your friends and share my channel with your friends. Subscribe to my channel and support me. Also, do not forget to press the bell icon so that you will be notified by my future videos, as I will be providing this kind of videos uh, in the future. Thanks for watching. Until the next video, take care and bye.